Hey everybody, welcome back to NTRAS. So in this video, we're going to talk a little bit about what networking is moving toward today. So for those of you that are wanting to get into the future of networking, one of the first things you really have to worry about is a good server infrastructure. So I have here VMware with vCenter Server 8 and a couple of ESXi 8 hosts. In this case, I'm running two super micros, the Sys E300 9D 8CN 8TP. Basically, it's a desktop Internet of Things kind of small form server that works really well as a virtual host. So I'm going to come in here. Let's see, we have 8 NICs, 16 logical processors, and they're each at 2.3 gigahertz. So let me see if I can get some more information for you on here. So physical adapters. Out of the box, it comes with, I believe, 4 1 gig interfaces, 2 10 gig copper connections, and 2 10 gig SFP Plus connections. Now keep in mind, these servers are a little bit old now, so you'll see them running some of the older Intel D series processors. But when it comes to connectivity and performance, once again, if you want a decent but fairly cheap system with 10 gig connectivity out of the box, Supermicro are some of the perfect examples. In this case, these boxes come for about $4,000, so they're actually kind of cheap as compared to some more of the big name brands. However, the reason I like to bring these up first and foremost is because they are basically noiseless. They make little to no noise at all. On the back end, I of course have my Ubiquiti I can't remember the exact model numbers, but I got the 10 gig copper 24 port switches, and of course the I think, is it a 48 port 10 gig aggregate switches. So as you can see here from my physical adapters, I am only running 10 gig connectivity with the distributed port groups for data and storage. So I basically have 40 gigabits of throughput on these systems. But here's where I want to really get into what this video is about. Creating a self-sufficient kind of server environment. Once again, I am running ESXi. You'll see here I'm running a Cisco Secure Firewall Management Center, or Cisco's FMC, that's going to be managing my FTD firewalls. Now the reason I bring this up is because everything is becoming server-side. When you think about UCS Manager, well, that manages all of your physical hardware in your servers. If you look at FMC, well, they have a virtual edition. DNA Center has a virtual edition. What else we have? Yes, DNA Center for SD Access, if you want software-defined access layer in your enterprise. ACI, the application-centric infrastructure, I believe, is a software solution for SD Data Center. So all of your data center Cisco Nexus 9Ks, you can either manage them via CLI, which I wouldn't recommend because FEXs are being unsupported soon, so you'll have to learn something like VXLAN at the CLI. And although doable, ACI costs about the same as regular Nexus switches do, because you're extrapolating the management off of the device itself and onto the ACI basically virtual machines, the application becoming software defined. SD-WAN, as an example, also is pretty much completely configured and controlled via software defined or virtual machines, and those virtual machines are basically going to control everything. Now the point of this is for all of the network engineers out there right now, for those like me have been in the industry for like 20 years, we realize that we can't get by with CLI anymore. We need to kind of move on from that, which is kind of my recommendation for a lot of network guys out there. We really need to start understanding virtualization. Cisco's model a few years back was to kind of consolidate or converge all of the networks together. So you have compute, you have networking, you have storage, you have security, and it all goes under a single Cisco umbrella, as they like to call their other system, but I like to call it an umbrella of converged systems. So, like for example, I have my 2 ESXi hosts. I put them into a VSAN cluster. As you can see here, I have a VSAN and non-VSAN. One of the reasons I bring this up is because, well, the whole self-containment I mentioned previously. I want these 2 hosts to be able to do network, compute, and storage by themselves. Keep in mind, in the real world, VSAN does cost a lot of money depending on the features and functions that you want. But, you know, for the time being, I just want to show you my VSAN environment. And VMware has come a long way when it comes to health, metrics, troubleshooting, and just making sure everything works with wizards and whatnot. They actually have a really cool VSAN wizard that you can use to set all this up. And if I ever get to the point where I create that VSAN video, you're going to notice I had a lot of troubles when I didn't follow the wizard. So keep that in mind. First of all, Skyline Health is really cool because they have, it looks like, nearly 70 health findings that you can go through and make sure your VSAN is functioning. Now in this case, of course, NTP is having issues. It'll tell you the category, the impact area. In this case, it's just compliance. It doesn't have anything to do with messing things up, so to speak. However, it gives you a description and, of course, a possible risk if no action is taken. The really cool thing I found is this new troubleshoot option. So you can actually come in here and it'll tell you about all your hosts and the status of each of them. So in this case, you're going to notice my 6.22 is having time issues. It gives us some recommendations to fix the issue, such as enabling the NTP service on vCenter and the hosts. In this case, I'm trying to use NTP as my switch gateway. Once again, I need to look into that. But it also gives you alternative information, reset the clock time of vCenter and the host to match if you want to do it manually rather than using NTP. But yeah, that is Skyline Health. We can come in here into virtual objects, which will show you all of your objects that are being used by VSAN. In this case, let's look at the FMCV, and you're going to notice I have hard disk 1, swap object, and of course the VM home folder. All these are healthy. They are on a storage policy, and you have various identifiers to the right. Now, one of the things you probably need to know first and foremost is VSAN is a storage policy driven feature. So you don't just turn it on and let it do its thing. You actually have to get into some of the storage policies in order to make VSAN really function properly. We'll get into that in just a minute. We have the resyncing objects, depending on the VSAN type that you have. In my case, it is a simple mirror. So my 2 hosts, 6.61 and 6.62, basically have a mirror of all of my VSAN protected hosts, or at least the virtual machines that take part in this VSAN storage policy. Let's see, resyncing objects, yes. Proactive tests. So once in a while you might want to go through proactive tests to make sure the VM creation, network performance, and of course storage performance, is up to par. Now this is where it gets really cool. Capacity. So looking at the capacity usage, you're going to notice that I have two 4 terabyte drives acting as my capacity. So I am using 1.4 terabytes of physical space. The next part though, the deduplication and compression. You can only do dedupe and compression if you have an all-flash VSAN. In this case, I have an NVMe for my performance tier, and I have an SSD for my capacity tier. We'll talk about that in a moment as well. But you're going to notice that I have 1.1 terabytes of space that has been deduplicated or compressed. So I have a ratio of 2.08 to 1. Amount of capacity versus saved and actually written. So I have 1.4 terabytes out of 7.28, which gives me 5.87 terabytes available from 2 hosts with 2 4 terabyte drives. So, I have more space on these 2 hosts, SSD-wise, than I did in my previous centralized storage. And they just mirror between one another. Down here, we also have a what-if analysis that is pretty cool. You select the policy you want, in this case, 2-host mirror. I can't remember what the NR stands for, but hopefully I'll remember. Effective free space of a new workload would be 2.59 ter. You can consider the deduplication and compression based on some existing metrics. You're going to notice that if all thin provisioned and objects were at full capacity, it would require 6.3 terabytes, or 86% of my total available capacity. So you're going to see here that if you don't want to use thin provisioning, or you don't want to consider deduplication and compression, well, capacity is going to skyrocket really quick. Once again, thin provisioning and deduplication and compression take me from 13 terabytes down to 6, and then of course thin takes me down from 6.3 down to 1.4. So again, without deduplication and compression, I'm looking at about 13 terabytes of required space. Let's keep that in mind. Down here we have a usage breakdown before dedupe and compression. So you'll see here that I have my VMDKs, or my virtual machine virtual hard drives. I'm using 910 gigs for VMDKs. Now once again, I say I'm using 910 because that is pre-mirror or pre-replica. So technically I'm using about 1.78 terabytes primary plus replica. VM home objects is 14 gigs. Swap objects is half a gig. It's not a big deal. I have user objects because I have an iSCSI target connected to my VSAN. So basically I have my VSAN, my 2 hosts, and then I have a Proxmox cluster that ties into iSCSI and a Hyper-V cluster that tie into iSCSI. So I technically have 2 hosts running local VSAN and 3 hosts running iSCSI for Hyper-V and for Proxmox. And then of course lastly we have system usage. Performance objects, overhead, checksum, dedupe and compression overhead, and of course native trace. One thing you do want to be aware of though is deduplication and compression have their own overhead. So if you have a savings of less than, say, 300 gigs, you might not want to enable dedupe and compression because it's just a waste of CPU, memory, and storage cycles. So keep that in mind. There is a little bit of overhead there. As far as performance is concerned, no, I do not want to get feedback at this time. The performance will tell you VM, backend, iSCSI, IO Insight, and VSAN Direct, whichever one of those you're using, and whatever type of metrics you want, such as cluster level, top contributors, or specific VMs. In this case, let me do top contributors, and we can select a point in time and what metric we want to use. In this case, we can look at latency. You'll see that I have a latency that maxes out at about 1.5 milliseconds. And my top contributors, my VSAN witness is pretty much my top contributor to my VSAN latency. vCenter server, my domain controllers, and then everything else just goes down the way. You'll see that we have the read latency and the write latency. And you'll notice that read latency, well, a lot of the VMs don't really do much. Everything's running in memory, so nothing's going on. My witness server and my vCenter have a really low read latency, but you'll notice sometimes write latency is the one that has the problem. And the reason why we have write latency is because I am doing a mirror. If we remember back from my capacity, we have a primary and we have a replica. So once that VM writes to the host that it's on, it needs to transfer that information through the network to the replica host. In this case, between 621 and 622. Let's see, what else do we have? We can look at IOPS. I'm running 52 IOPS, so it's really low. And throughput, I have, it looks to be a max of 807 kilobytes a second. Yeah, not a lot going on my network. Back end, we can look at IOPS throughput, latency, and congestion, if there is any. Thank you, Jack. Dogs always love to make noise when I'm recording. Cindy boy. iSCSI, so it'll tell you if there's any iSCSI issues. In this case, it looks like I have a lot of, what do you call it? Be the equivalent of like TCP MSS. And sadly, I can't remember what MSS stands for, but basically when a system needs information, it sends a lot all at once, and then it pulls back and stops. Sends a lot, pulls back, receives a lot, pulls back, etc. So you're going to see that I'm going from like a read latency of 0, and it's going all the way up to 225 milliseconds. I don't think that's good, but once again, it's for iSCSI, it's for my Hyper-V lab, not really worried about it. So it'll be something to think about in the future. Performance diagnostics. We have a vSAN performance service and customer experience, support, and a data migration pre-check. So if we wanted to look at an object for this disk group, and you can't do it with deduplication and compression. What are you going to do? So let's see. I guess what people would probably be more interested in, rather than the monitoring, of course, once it's up and running, monitoring is your best friend. I love the vSAN and the Skyline Health. It tells so much good information. But vSAN. So first off, you're going to look at all the services that are available with vSAN. So you have storage, so you can look at a distributed layer of software that runs natively as a part of ESXi rather than some other systems that might create storage virtual machines, and then all of the hosts connect to the internal virtual machines for their storage. Well, this is natively on the hypervisor, and it has direct connectivity to your hardware. Support Insight is for analytics and health. I do not have that, but I do have the performance service running. You can run file services on your VSAN, so you can create NFS or SMB shares directly to your VSAN data store, which basically gets distributed in their file system for VSAN. Like I showed you before on iSCSI, I basically have an iSCSI target. What do you call it? I have a LUN carved out that is presented to the iSCSI initiators, and that iSCSI data is replicated between my two hosts. And of course, you can run file shares for NFS and SMB if you want to get rid of your SANs altogether and run everything on a VSAN. Keep in mind, however, one of the issues I'm seeing with iSCSI right now is I have two VSAN iSCSI hosts, but I can only connect to one of them. So I have not had the ability to shut down 6.21 to see if iSCSI still works. Maybe in another episode we'll talk a little bit more about that. We also have the network. RDMA is currently disabled. I'm not even sure I support remote direct memory access. Let's see. Here's the VSAN iSCSI target service I told you about. We configure iSCSI network VMK1, the default port, which is 3260. I'm currently not running authentication, and there's my home object storage policy, the VSAN 2-host mirror, and its status and health. You'll notice that I have turned on deduplication and compression. I have not turned on data at rest or data in transit encryption because, well, I don't really need to worry about those IOPS or CPUs being in use because I don't have anything that I need to keep secret. I show you guys everything anyway. We have reservations and alerts. So we have operational reserve, host rebuild reserve, warning and error alerts as well. Lastly, we have various advanced options such as object repair times. So if you have an issue with one of your replicas, which with VSAN you can have got up to 4 replicas or more, if I'm not mistaken, which basically means for every 100 gigs you write, you have 400 gigs used. I think that's the max that I've seen so far. I think the lowest is what they call a RAID 5 for VSAN, where you use 1.33%, as I should say, 133% of actual data written because it's a RAID 5. You have, and if I'm not mistaken, I need to look into RAID 5. I only have 2 hosts, and you need a minimum of like 5 for this. So you have 3 hosts, right? You put part of the data on this host, half the data on this host, and then a parity on a third host. So 100% plus 33%. Not sure how that works, but at least that's what I saw for my storage profiles. From there, let's actually go into the storage policy. This, of course, is in the policies and profiles under the, what would you call this, the menu. From here, storage policies, and you can look at all of the existing policies out there. In this case, I created my VSAN 2-host mirror, no redundancy. So NR is no redundancy. 2 host node mirror, no redundancy, 100 gigs becomes 200 gigs or 2 to 1. I have placement, storage type is VSAN, site disaster tolerance is a 2 node cluster with host mirroring. No data redundancy, and number of stripes per object is 1. So a single stripe per object. Once again, it's like a mirror. We're going to write a stripe to host 1. We're going to mirror that same stripe to host 2. We can configure thick provisioning for object space reservation. In this case, I just love thin. We have an IOPS limit option, flash read cache reservations, object checksums, which I like to not disable this because you always want to make sure the data has the same hash when it's being mirrored. Not really sure what forced provisioning is, but encryption is no preference, space efficiency is no preference, and my storage tier, of course, is all flash. Having it all flash enables me to do the deduplication and compression. You'll see here we have other rule sets such as VSAN Direct and VMFS. Conserve space when possible. From here you can look at the VM compliance to see if there's anything out of compliance, which we're all good. No VM templates and storage compatibility. So you'll notice here I have a local storage, what do you call it? A local data store, which you're going to notice there's actually an error because of this. If you go back to Skyline Health, if you have a VSAN data store and a regular host data store sharing the same controller, it'll give you an error. So it's something you really need to look at and be aware of. But in any case, you're going to see here that I have my VSAN data store. Let me go back to my hosts really quick just so I can show you the storage configuration. So my storage adapters, I have 2 AHCI controllers, the VM host bus adapter, I'm running a SSD 970 EVO, and a USB storage controller because I'm actually running ESXi off of a USB thumb drive, basically. If we look at the storage devices, you're going to notice here that I have that local USB that ESXi is installed on. I have my 4 terabyte SSD that's in the VSAN data store. Basically, this is my capacity. I have a Samsung 970 EVO 2 terabyte as my performance tier. And of course, I just have some random 500 gig I'm using. And we'll talk about why I have that in just a moment. So let's come back here to rules. Let's see, is there a way for me to modify this rule? So let me just edit. Next. So there's a bunch of policies that you can create, such as host-based rules. So you'll see we have host-based services that come up. Rules for VSAN, VSAN Direct, VMFS, which, once again, those were the rules you saw. And, of course, tag-based placement rules if you want to do tag-based placement. I only have a mirror. I'm not really worried about that. I'm really only using the VSAN storage. The other two are pretty unnecessary anyway. And then there are rules for storage consumption domain topology. The storage policy will be applied to data store specific rules, which adds consumption domain. Well, I'm not actually going to configure these, but I want you to see them in the edit of the policy. Encryption is turned off. Storage I/O control is turned off because, once again, I really don't care about those things. Host-based storage rules cannot be empty. That was weird. Anyway, for 4, VSAN, actually, you know what? Let me go back and just disable that because I don't want to mess something up. Site disaster tolerance defines whether to use a standard, stretched, or 2-node cluster. In the case of stretched clusters, whether data is mirrored at both sites or whether it is constrained within only one of the sites in the cluster. In the case of a 2-node cluster, the data is mirrored at both hosts. So technically, host mirroring 2-node cluster is basically a stretched cluster. Like site mirroring stretched cluster, but I'm not doing 2 sites, I'm doing a stretched cluster with 2 nodes. It didn't make any bloody sense to me either, but we'll talk about that when we get there. And then, of course, failures to tolerate defines the number of failures a storage object can tolerate. Now, in this case, a mirror, I have 2 storage objects per object, because it's a mirror. Okay, for stretched clusters defines the number of disks or host failures a storage object can tolerate for each of the sites. So say, for example, you have 2 different physical locations. Each physical location has a RAID 5, so 5 hosts in each. You're going to have this domain in the primary site and maybe a mirror domain. Within those domains, you have a standard or stretched cluster, depending on the configuration. So a RAID 5 and a RAID 5. The RAID 5 in the primary will be mirrored, or not, to the secondary. And that also goes into object failures. So if you have redundancy, so RAID 5 plus redundancy means you're using like 2.66 port per domain because it's a RAID 5 or a mirror of a RAID 5, which you could consider like a RAID 50. And then that RAID 50 can be mirrored over to the other site with a RAID 5 or 50 or whatever. So you can specify how many hosts you can lose. You can specify how many storage objects you can lose, and potentially disks as well. There's a lot to VSAN, a lot to unpack. Let's see. For non-stretched clusters, define the number of disk, host, or fault domain failures. A fault domain could also be a rack. So say, for example, you have 2 racks with 5 hosts each. 5 and 5. Each of those 5, RAID 5 or whatever, would be its own fault domain. So if the primary fault domain goes down, the other fault domain that's been mirrored to will start processing the I/O. So you have a fault domain within the data center, within the disks, within the storage object, and then, of course, a remote site for another set of domains or whatever you have. The number of required fault domains, hosts within a site for stretched cluster in order to tolerate n failures is 2n plus 1 for mirroring, 4 or 6 for erasure coding. Erasure coding is basically RAID 5 or RAID 6. Let's see, failures would be 1 or 2 respectively. So if you have a RAID 5, just like RAID 5 with hard drives, you have 3 disks, you can lose 1, and it'll still function. This is basically what we're talking about. Disks to VSAN, except instead of disks, we're talking hosts. But once again, for a RAID 5, you need 5 hosts. For a RAID 6, I believe you need 7. But we'll see that in a minute. RAID 5 and 6 is only available on all flash systems, so if you have a flash performance and a spindle capacity, you can't do RAID 5 or 6. Because it's like caching. It writes everything to the performance tier, NVMe or SSD, replicates that over, and then pushes that data down to the capacity. So let's see, host mirroring 2-node cluster. For each 100 gigs, you would use 200. No, all right, 100 is 100. There's no mirroring. With site mirroring, 100 becomes 200, because technically host mirroring and site mirroring is the same thing, but different. Let's see, none, keep data on preferred. None, keep data on secondary. Well, it's 1-to-1, basically. And then, of course, none stretched cluster. So let's just go to standard cluster, no site disaster tolerance, and specify what type of redundancy we want. Now, this is the rub. There's the site disaster tolerance and then the failures to tolerate. Now, we talked about before, if you do a site mirroring, that's 2 different sites. Site disaster tolerance. So one site mirrors to another. That's all you have. You have mirroring or no mirroring when it comes to site disaster. When it comes to failures to tolerate, this is where you're talking about the hosts themselves. In this case, we have one failure or mirroring. A site mirrored stretched cluster requires 400 gigs of usable space written for 100 gigs of actual VM, because you have 2 sites being mirrored, 100 becomes 200, and then a RAID within the local cluster is basically mirrored again. If you do none, RAID 1, 100 becomes 200, you're just mirroring within a standard cluster. So let's just keep it with this for now. No data redundancy and host affinity, only applicable for SNA workloads. Don't really know what that is at the moment, but we can learn more. RAID 5 erasure coding consumes storage space for 100 gig VM disk would be 133 or 133%. 2 failures with RAID 1 means there's going to be 2 mirrors, a primary and 2 replicas. So you'll have 300 gigs. 2 failures with RAID 6, 100 becomes 150. And then lastly, 3 failures with RAID 1, 100 becomes 400. Once again, this is within a single site. Now let's do a site mirroring stretched cluster with 3 failures. 100 gigs of VM space actually writes 800 gigs of data. So yeah, if you want to have like data center redundancy and many failure to tolerate, it's going to consume a lot of space. But if you're using deduplication and compression, well, you probably don't have to worry about that. Now, I could have sworn this thing told me about what you need for these to work. So like RAID 5 as an example. I could have sworn it did, but apparently not. I guess not. Storage rules. This is where we specify encryption, space efficiency, and storage tier if you have a hybrid or all flash. Space efficiency, of course, deduplication and compression. Compression only. No efficiency or no preference. In this case, I just have it set to no preference because you can specify this somewhere else. Let's see. Disk stripes per object. We have that set to 1 because I'm just doing a mirror. You can change this up to 12 stripes per object. IOP limit, object space reservation from thin, 25, 50, 75, and thick. Disable the checksum and force the provisioning. So if this option is turned on, the object will be provisioned even if the policy specified in the storage policy is not satisfied with the resource currently available in the cluster. Basically, if you try to do something and that something can't really be done based on policy, it'll give you an error and say it can't be done. Forced provisioning will just make it work. And then, of course, tags. Placement of VMs. Yeah, I'm not going to worry about that for the moment. Remove. Next. VSAN direct data store placement defines where to place the data. We'll talk about that a little later. VMFS conserve space when possible, fully initialized, and reserve space. I just like to do conserve space if possible, because then you're not just wasting a bunch of, rights. Here's the tag-based placement we just saw. It's the same thing, apparently. Okay, at least let me remove tag now. Let's see. Consumption domain. Storage topology type is zonal. Describes the requirement of storage availability in vSphere zones. With a value of zonal, the storage is required to be local to only a single zone, used when co-locating workloads and their corresponding storage on the same consumption domain. Yeah, I have no idea what any of that means. Sorry. Something to look into. Storage compatibility. Well, it looks like there's nothing compatible. Why is it incompatible? Let me look at VSAN. Data store does not match current VM policy. Data store does not satisfy compatibility since it does not support one or more required properties. Data store is not mounted on any availability zone. Okay. You also notice here that I have a couple of NFS shares as well. So let's go back to my availability, host, no redundancy, next. It's still incompatible. I wonder why. Thin provisioning, all flash, no preference, no tags, host mirroring, no redundancy, and there you go. So you're going to notice that there's a lot of options, but the nice thing about VMware today in version 8, they really make it really easy to tell you that you can or cannot do that. So what I want to do really quick is look at data redundancy, RAID 1 mirroring. Next, and it's not compatible. So, data store does not match current VM policy. So this is what I was looking for earlier. Data store does not match current VM policy. Policy specified requires 3 disk groups, disks contributing storage, but only found 1. Now once again, if you remember, I told you before, I have a single performance disk and a single capacity disk. If I want to do host mirroring for a 2-node cluster and RAID 1 mirroring for failures to tolerate, I need 3 disks of capacity, I think, per host. And I only have 1. So, the reason I bring this up is for design, implementation, right? So if you're sitting here as whomever, if you're sitting here as whomever saying, well, we want to have a VSAN policy that allows us to do site mirroring with a 2-failure RAID 5 erasure coding, data store does not match current policy. It requires 6 hosts contributing all flash storage, but only found 1. Now, once again, I am in a 2-node stretched cluster. So I need 6 hosts to do this. Here's the problem, though. I need 6 hosts. But what is it telling me for the RAID 6? Just the 6 hosts? What about local drives? Do I need to worry about the amount of local drives? Just looking at this right now, I have no idea. All it's telling me is, well, now I need 4 hosts. So I was wrong. It's not 5. For a RAID 5, it requires 4 hosts contributing all flash storage. I only have 2. So I would have to buy 2 more of these super micros to do a RAID 5 erasure coding. But my host only supports 1 NVMe and 1 2230, which sucks basically. There's no point in doing that, and 1 SSD. So I can only do a single capacity. If I want to do something a little cooler, a little better, I need to do some reading and be like, okay, if I want to do a standard cluster with RAID 5 erasure coding, what do I need? Data store does not match policy. Invalid number of failures to tolerate for RAID 5.6. I don't know what that means. I wish VMware would have included a little bit more here. What do I need to do? Do I need to add 3 disks? Do I need to add 2 hosts? What do I need to do? I mean, to be honest, if you're doing VSAN, you probably have done a little bit of research before this, but I really wish that VMware would have included that, because now I have to, okay, I can't know what I need to do. I need to go do some research. What does erasure coding require? 4 hosts? How many disks do I need? Will 1 disk work? So I can do what I normally do, just buy 2 new hosts with the exact same configuration and see if it works. But alas, no. I know we're running a little long here, but there's one last thing I need to talk to you about. A 2-node mirror. You can't do a 2-node mirror. Supported. A 2-node mirror only works if you have a witness or a third host. Now, one of the cool things that VMware provided is a virtual witness. If you remember before, my 6.16 down here is my virtual witness. It's running ESXi 801. It's got the Intel D. Well, what is it? Well, remember my workloads from before? My NTR VSW01 is 6.16. So I'm running a virtual witness as a host in vCenter that provides witness services for my 2-host mirror. Pretty cool, huh? One of the things I could do, I could actually buy 1 more physical hosts, because RAID 1 standard cluster, RAID 1 requires 3 hosts minimum. I only had 2 hosts, so I had to figure out how to kind of fudge it. And by fudging it, I created the virtual witness. Now keep in mind, you're technically supposed to have an enterprise environment set up, like say 4 hosts, erasure coding with a extra failure domain or a RAID 1 on the object level. and then you run the vCenter server witness on that cluster, and then it provides witness services to whatever two hosts, whatever you have out there. So like as an example, I could create a new cluster and enable VSAN, which is what you have to do because it's a VSAN cluster. It's the only way you can enable VSAN is in a cluster. So I could create a whole new VSAN cluster called iNet Edge HQ or DC1 or whatever. And these two hosts would now be able to do a mirrored cluster because they can point to this virtual witness. Now, I think if we look at the quick start configuration, yes, cluster is now successfully configured. This is basically the wizard for VSAN. So you can come here to quick start and just run through these three items to create your VSAN for you. I can't remember where it is. But I really don't remember. I could have sworn it was here under quick start. So he's not a part of the cluster. 6.16, my virtual witness, not a part of the cluster. He is the witness running on vCenter for my two host mirror VSAN cluster. Licensing. Okay. You also have to have a VSAN license. Here we go. It's under Configure Disk Management and Fault Domains. So looking at disk management first, you're going to notice here we have an external witness host for VSAN stretched cluster because I am running a 2-node mirrored stretched cluster, and I have 2 fault domains, preferred and secondary. From each of these you can view the disks. So I have my disk group 1. It'll tell us what is ineligible and unclaimed. So if you add a new drive to one of these, you can come in here, click, and mark it as an SSD or HDD and erase partitions, or you can claim it. But for now, once again, we have our VSAN cache or performance tier, which is my NVMe flash 2 terabytes, and my VSAN capacity is my 4 terabyte SSD. You're going to see that on both of these hosts. They're basically exactly the same. 6.16, of course, is my virtual witness, and it, oddly enough, also has to have a VSAN cache of 10 gigs and a VSAN capacity of 350 gigs using about 5 1/4. Let's see. We can go to view host objects, which shows us basically what we saw before on monitor virtual objects. But you'll be able to see this configuration under the disk management for an individual host. So let's just look at 622, view host objects. Let's look at my... Yeah, he's a non-local VM. He's actually not on VSAN storage. So let's look at the FMCV. You'll see here all the same information we saw before, and we're good to go. Oh, by the way, you can have multiple disk groups for your VSANs as well. Host list, view cluster objects, same thing. But fault domains is where you really need to look to see how you're configured for all of your domains. Now, 2-node VSAN, stretched cluster. I have a primary, preferred, which would be my primary data center, my secondary data center, and the witness host. In this case, the witness host is already selected, 6.16, and that virtual machine is acting as the witness for my cluster. And that's how I got VSAN to work, having only 2 hosts instead of 3. Now, I do have to play around a bit with the clustering, and if I introduce a 3rd and or 4th host, how do I modify this existing configuration from a 2-node mirrored stretched cluster to a non-normal cluster with mirroring or erasure coding RAID 5. So again, that's something I'll have to look into. But yeah, last but not least, let's look at the data store itself, my VSAN data store. It's got my 7.28 terabytes connected to 2 hosts. I have 21 virtual machines. And we can come in here and look at all the events. We can look at the VSAN capacity. It's all the same stuff we saw before under monitor for the cluster. We can look at the various configurations for it, default storage policy. So if I do not create a storage policy for an individual VM, this will be the default. Permissions, files, hosts, VMs, etc. So once again, the whole point of this video is to kind of give an introduction to why network engineers really need to start looking into being virtual engineers, or as I would like to call Cisco engineers, not network engineers, security engineers, systems engineers, storage engineers. Because with, like I said, UCS Manager, with Hyperflex, with VSAN, with converged everything, software defined everything, well, I mean, here's my FMC. My standalone FTD devices, firepower threat defense appliances, well, they're going to be managed via FMC. There's no more local management. So it's all going to be managed via a VM living on my servers. So as a network engineer, if I can, be a part of the virtual data team or whatever, I'll have to have access to these VMs so I can look at, log in, troubleshoot, etc. Now keep in mind, I can come in here and create a new folder called like a new network folder, a new VM and template folder, like network stuff. From here, I can move my FMC into the network stuff folder, and then I can provide permissions to whatever user/group, so domain users, whatever. Say if that was like a network engineers group. So the network engineers group would now be able to log in, and they'd have a role of whatever to only this folder and the VMs in this folder. So like read only or view. You can't really do much. You're a network engineer, you're responsible for this device, but you can't do anything with it. I mean, a lot of times the system guys don't want you to mess with it because adding hard drives, adding memory, CPUs, blah, 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 can cause contention. But Me as a Cisco data center engineer, I want to have full control over my virtual environment, to have full control over my server environment, physical hardware, to my appliances, to my virtual appliances, and everything in between. So I would highly recommend anyone going into the networking, the cyber Cisco world, mostly just the Cisco world, to really get a good understanding of UCS Manager and the Fabric Interconnects, Nexus 9Ks and ACI, DNA Center, FMCV, virtual routers, virtual switches, virtual everything, basically. Everything is virtual and software-defined future. So if you want to keep up, CLI is great. It really is. It still comes in handy for a lot of things. But moving forward, CLI is going away. The only CLI you may have is APIs connecting into applications, or the CLI on servers themselves. I mean, FMCV. I need to understand how Linux works a little bit so I can understand how to configure my application that is running on Linux, that's running on an ESXi host. And one of the reasons I mention ESXi is because, well, there are some applications that install really easily on ESXi, but are complete pain going anywhere else. So unless you have OVF compatibility, I mean, like Proxmox, it's painful to get an OVF installed on there. Some people, yes, you might have figured it out, it may seem easy, but my life's in VMware. I right click, I do deploy OVF template, I select, but done. And it works. I don't have to worry about getting the QCOW2 images, or converting VMs from one platform to another. Hyper-V, I don't think has it at all. I mean, it might have it in SCVMM, but I don't know. ESXi, honestly, is free. Get a host like me. I have, once again, I know I paid like $4,000 for it, but it's got 256 gigs of RAM. It's got 8 cores with hyper-threading running at 2.3 gigahertz. I installed a 2 terabyte performance, 4 terabyte capacity. I installed ESXi on a thumb drive and use that single host as your platform to learn all this stuff. I mean, my FMCV, it's got 4 virtual CPUs and 32 gigs of RAM. Your host computer you're probably playing games on or whatever probably only has 32 gigs of RAM. $4,000 for a great investment into learning all of this new software coming out, that networking and even cyber. I mean, look at Palo Alto. They have their panoramas. They have their virtual firewalls. Like I said, FMC, ACI, etc. So the first thing I would really tell a new network engineer to do, along with studying Cisco, is to learn VMware and to learn how all of this virtualization ties into software-defined everything. So yep, on that, I know the video's gone about an hour now. I hope you enjoyed looking at vCenter and getting to know VSAN a little bit. So for now, until next time, see you in the next one.